Solving an algebraic equation often begins with needing to simplify the expressions that are part of that equation. Looking at this particular expression, we notice that there is a division bar that groups the numerator as a trinomial and the denominator as a trinomial. Before we can divide then, we need to consider step 1, are there factors that could be rewritten as part of the numerator? We notice that there is a term for y which can be factored out of each trinomial, and so it's good habit to then note that we have replaced the numerator. In like fashion, we will factor the denominator. It is good habit to compare the trinomials to see if by chance they're identical and could be divided out. That's not the case, so instead we need to consider whether they could be themselves factored. In the denominator, we notice that this is really y minus 3 times y plus 2, and the numerator is also factorable. At this point, with a lot of work, it is a good idea to rewrite so that we have a clearer idea of what our factors are in each our numerator and our denominator. This allows us to notice that we do have like factors that could be divided. For instance, y divides y, leaving 1 in each location, and the term y minus 3 matches the term y minus 3, so they can be divided, leaving a factor of 1 in their place. It is not unusual to leave the form as a factored form, or you might choose to distribute so that the most simplified form has no remaining parentheses in either the numerator or denominator. In either case, we need to finish by considering step 3. What values for which the entire expression is undefined? In looking at the end result, we can see that y is not allowed to take on a value of negative 2. That would create a 0 in denominator. Returning to earlier steps, we notice there was also a factor that the y equaling 3 would have created a 0, or y being a single factor could also itself not equal 0. Therefore, we have 3 values for which this polynomial expression is undefined.